Morning, everyone. Black holes are one of the strangest things in existence. They don't seem to make any sense at all. Today, in this presentation, we will shed light on some very key questions. Where do they come from? And what happens if you fall into one? My name is Nanahal, and my partner's name is Sunil. How does a black hole occur? A black hole is formed when the core of a star collapses, causing the star to implode. Stars are a massive collection that consists mostly of hydrogen atoms. These hydrogen atoms collapse under the star's own gravity. In its core, nuclear fusion crushes hydrogen atoms into helium gas, releasing an incredible amount of energy as radiation. This radiation and gravity act in harmony, creating perfect balance. For stars with way more mass than our own sun, can achieve higher fusion rates until they hit iron. Unlike the elements fused before, the fusion process to create iron doesn't produce any energy. This means that iron just builds up at the core until the balance of radiation and gravity is broken. For a fraction of a second, the star implodes, moving to a quarter speed of light, engulfing more mass into its core. It is at this moment the star dies from a supernova explosion that the heavier elements in the universe are created. The implosion either produces a neutron star, which you can see to your left, or if the mass is large enough, the entirety collapses to produce a black hole, which you can see on your right. So what is it? If you were to look at a black hole, you would be looking at the event horizon. In order to escape the gravitational pull of the hole, you would need to travel faster than the speed of light, which is unfortunately not possible. What's the whole part about? So if we're looking at the event horizon, what is the whole part? The singularity. No one knows what exactly a singularity is. A singularity may be indefinitely dense or something completely different. At this point in time, we just don't know. It's like dividing by zero error. It's undefined. Oh, and by the way, black holes do not suck things up like a vacuum cleaner. If we were to swap the sun with an equally massive black hole, nothing much would change for Earth, except that we would freeze to death, of course. So what would happen if you fell into a hole? Well, time is different around black holes. From the outside, you seem to slow down. As you approach the event horizon, time passes slower for you. At some point, you would appear to freeze in time, slowly turn red, and disappear. While from your perspective, you can watch the rest of the universe in fast forward, kind of like seeing into the future. What happens next is unknown, but it could be one of two ways: death and or a faster death. Once you cross the event horizon, there is only one possible direction. The mass of a black hole is so concentrated that in some instances, a mere centimeter causes the gravity to act with 1,000,000 times more force on different parts of your body. Your cells tear away from one another and stretch more and more until you are nothing but a stream of plasma 1 atom wide. The other way, well, you die a very quick death. Very soon after you fall in and cross the event horizon, you would hit a firewall and cease to exist in an instant. Either way is unpleasant. How soon you would die depends on the mass of the black hole. A smaller black hole would kill you before you even enter the event horizon, while you could probably travel inside a supermassive one for quite a while. So basically, the further away from the singularity you are, the longer you live. Black holes come in different sizes. There are stellar mass black holes. They are a few times the mass of the sun and the diameter of an asteroid. And then there are supermassive black holes which are found at the heart of every galaxy and have been there for billions of years. This image shows us a supermassive black hole called 1ES, 1927 plus 654. In the left image, we can see that the black hole is very active and is feasting on the gases that surround it. However, in the right part of the image, it is clear that the energy has drained and the black hole is no longer active. This is due to a runaway star that struck the black hole and added negative energy and dispersed the gases that surrounded the black hole. Thus, the neutron star has disappeared. Currently, the largest supermassive black hole known is S 50,014 plus 81, 40 billion times the mass of our sun. It is 236.7 billion kilometers in diameter, which is 47 times the distance from the sun to Pluto. As powerful as black holes are, they do eventually evaporate through a process called Hawking radiation. To understand how this works, we have to look at empty space. You might all be wondering, what are you talking about? How exactly does this process work? Black holes work as a siphon system. They siphon particles to another space in the universe. While they siphon these particles, they also feast on them. Due to massive power and intense gravitational pull, black holes sometimes siphon all the particles around them, leaving them nothing to feed on. And the black holes begin evaporation slowly. You might wonder, are there particles in space? Empty space is not really empty space, but filled with virtual particles popping into existence and annihilating each other again. When this happens right on the edge of a black hole, one of the particles falls into the hole, while the other one escapes. The one that falls into the hole is known as the negative particle. The other one becomes a real particle. The negative particle causes the black hole to lose energy. This happens slowly at first, but gets faster as the black hole starts to shrink. Then what happens? After the black hole swallows up the negative particle, it slowly begins to radiate its mass into energy, thus slowly evaporating. And finally, thank you everyone for watching. Enjoy your day.